This question gives us the function g of x is x squared plus x minus 20 divided by 2x squared plus 8x minus 10. We'd like to find the domain, find vertical asymptotes, horizontal asymptotes, slant asymptotes, x-intercepts, and y-intercepts. So let's first think about the domain. Remember, you cannot divide by 0. You cannot divide by 0. So when you think about when is the denominator equal to 0? So what I have downstairs is 2x squared plus 8x minus 10. That cannot be 0. So let's find out when it is 0. We first factor out the 2. I get 2 times x squared plus 4x minus 5 is 0. I need to factor that, so I will do that. So we have x squared, we have minus 5, and the middle term is plus 4x. So x squared will be x times x. Negative 5 will be 5 times negative 1. So I get plus 5x here. I get minus 1x here, adding up to 4x. So this becomes x plus 5x minus 1. So I get 2 times x plus 5x minus 1. Remember, the denominator cannot be 0. So looking at this, when is it 0? Well, when x plus 5 is 0, or when x minus 1 is 0. So when x is negative 5, or when x is 1, that will make the bottom 0. So for my domain, that has to be removed. Negative 5 must be removed from the real numbers. 1 must be removed from the real numbers to make our domain. So we shade everything else. Shade, shade, shade. So using interval notation, my answer is the interval from negative infinity to negative 5, union negative 5 to 1, union 1 to plus infinity. Now you may think you can immediately go to the vertical asymptotes and think maybe it's x equals negative 5, x equals 1, but not quite yet. There's something else we have to do first. So let's look at our equation. So we have g of x is x squared plus x minus 20 over, after we factored it, it was 2 times x plus 5 times x minus 1. So before I can define my vertical asymptotes, I need to make sure none of them divide out. So I'm going to also factor the numerator, and let's see how that behaves. What do we get? 2x, or x squared here, minus 20 here, plus 1x there. So we get x times x plus 5 minus 4. So we get plus 5x here, minus 4x. This becomes x plus 5 times x minus 4. And you will notice something divides out. Now, negative 5 is not in the domain. That makes the bottom 0. So that doesn't change. Our domain is still the same. So upstairs we have x plus 5 times x minus 4. Downstairs we have 2 times x plus 5 times x minus 1. And we notice what happens here. We notice that the x plus 5s divide out. But again, still negative 5 not in the domain. But now what I have is I have g of x is x minus 4 over 2 times x minus 1. So to get my vertical asymptotes, now I'm ready to do this. X minus 1 would have to be 0. That'll make the bottom 0. X minus 1 equals 0. X minus 1 is the only vertical asymptote. Now, what happens at -5? Remember, we said -5 is not in the domain. What we have there is a hole at x equals -5. So we'll try to look at that when we jump to the graph. Now, so we have our vertical asymptotes in our domain. What about our horizontal asymptote? To answer that question, I think I'm going to go back to the original. The original that we have here is g of x equals x squared plus x minus 20 over 2x squared plus 8x minus 10. To get the horizontal asymptotes, you think of very large numbers like 1,000. 1,000 squared is 1,000,000. So as far as 1,000,000 is concerned, these other things are negligible. So in essence, I just cover them up. And I say, well, the lower parts don't really matter. And my highest parts, x squared upstairs, 2x squared downstairs, they have the same order upstairs and downstairs. When that happens, you are going to have a horizontal asymptote. So what is my horizontal asymptote going to be? Well, 1x squared over 2x squared results in 1/2. So g of x, or y, will equal 1/2 as my horizontal asymptote. Now how about y-intercepts? Y-intercept for a function, there can only be one y-intercept. We look for g of 0. Plugging in 0, 0 squared plus 0 minus 20 over 2 times 0 squared plus 8 times 0 minus 10. 0 plus 0 minus 20, -20, 0 plus 0 minus 10, -10, and we get 2. So g of 0 is 2, which means we have a y-intercept at what? At x equals 2. Check that, at y equals 2, at the point 0, 2. Now how about the x-intercepts? What did we have? Well, after we reduced, we had this function. We had g of x is x minus 4 over 2 times x minus 1. So that we can use. And to find the x-intercepts, you set y equal to 0. Y, of course, is the same thing as setting g of x equal to 0. So we get 0 equals x minus 4 over 2 times x minus 1. When is the fraction equal to 0? A fraction is equal to 0 if the top is equal to 0. When is x minus 4 equal to 0? When x equals 4. So I believe I have an x-intercept when x is 4 and y is 0. So one y-intercept, one x-intercept, one vertical asymptote, no slant asymptotes. Again, the degree here is 2, the degree here is 2. The highest power upstairs is the same as the highest power downstairs. When that happens, you'll have a horizontal asymptote. You will not have a vertical asymptote. Now let's go take a look at Desmos and see all of these things and try to make sense of them. So our original question was, g of x equals, upstairs we had x squared plus x minus 20 divided by, downstairs we had 2x squared plus 8x minus 10. And see what you see here. Now, what did we say? We said we had a vertical asymptote where? At x equals 1. Do we see that on the graph? X equals 1. I'll draw it in here. And you can see the vertical asymptote. We said we had a horizontal asymptote at y equals 1/2. So can I find that? See if that looks right. Y equals 1/2. Again, we can zoom it out and you can see that even better as we move along. Domain, everything except we had to throw out what? We had to throw out 1 and we had to throw out -5. Now what's happening here at -5? Notice that. -5 is undefined. So when I move the cursor there actually is a hole in the graph. So I'd have to plug -5 in to figure out what the y value is, but you can see that is removed from our domain. So our domain does not include -5, does not include 1, as we said. We see our horizontal asymptote, we see our vertical asymptote. How about our x-intercept? We said we have one at 4, 0. Do you see it? 4, 0. Looks good. Our y-intercept we said was at 0, 2. There it is. That looks good. So we've checked all of our work.